So we're gonna warm up, and we are learning a formula for area, but we're gonna learn how to find area of a triangle using trig, because sometimes you don't have enough information, okay? So I'm gonna give you a hint, and I'm gonna give you a little spiel about trying things and trying to discover them and trying to start your pathways instead of just be told stuff. And I can tell you right now, by the time we're done with this, I think some of you are going to realize this is why it's super important that you almost like derive things and figure out where they come from, because they make more sense instead of me just telling you a formula. For instance, law of sines, we kind of derived it, so we like kind of derived it from using right triangles, and the formula probably sticks a little better than me just like telling you law of cosines. And so when you guys derive things and you have to kind of suffer through it, that's kind of what we're going to do today. We're going to learn an area formula. But what if you don't have all the information, so you can use trig? What if you have angles instead of like all the stuff you should have, okay? So we're gonna kind of do that. I want you guys to kind of set this up in such a way that you are trying to, what's the area of a triangle, by the way? Do you remember? 1/2 base times height, or base times height over 2. I'm gonna do the 1/2 base times height just because it'll help when we finish this. So my hint to you, let me get a brighter color. Stand out here. All right, let's take a look at just this first triangle, okay? And I really, really want you guys to embrace like trying to happen upon the formula yourself. Based on the way it's oriented, is the one that you usually choose to put on the flat, like pretend it's like sitting on the ground, okay? So what's our base for this one?
10.
Good. Do I know the height?
No.
No. So there's a problem. I don't know the height. But they did give me some angles, and I can sit there and try to finagle from there. So that's my hint to you, is I want you guys to figure out another way to represent height. And yes, I'm okay that you come up with the answers. In fact, I am so motivated to have you guys try to come up with the formula yourself, that everybody who's able to come up with it gets 5 points towards this homework assignment. I can come and stamp your notes. And then when you guys turn in your assignment, you're going to say, hey, Meryl, I have a stamp in my notes, and I get 5 points extra credit on my homework. I know it's not a ton, but it's hopefully it motivates you a little bit. So here's my hint to you. What is the height of a triangle, by the way? How do I draw that, and where does it occur?
Isn't it like in the middle of like?
It doesn't necessarily have to be the middle, but it's, yes, from the tallest point to the lowest point, okay? So usually you go to your tallest point, and like wherever that point is, you just drop it straight down. So a 90-degree drop right here is your guys' height, okay? That's your shortest distance. Now, if the angle I gave you is obtuse, how do you think I measure this one's height? It's on the outside. It still works though, okay? So here's the height, and I'm going to drop it straight down 90 degrees. So I actually technically form a little triangle out here, right? And that's also known as my height. Now, whatever one you want to do with, this one might be easier, and then we'll do this one together. I really want you guys to possibly see if you can derive or develop the formula yourself. So my hint to you, and don't think this is not don't trust, unless I tell you this is not like perfectly cut in half. So 5th period, I had a ton of people writing 5 right here. You do not know this measure. So the only measure you know is what from this little right triangle I was able to form.
Right angle?
I do know that it's a right angle. What else do I know? I do know that one angle is 35, and I'm trying to find the height. And then what else do I know? I do know that that length right there is 6. So based on what we know about right triangles, do you guys think you can happen upon the formula? Let's try to work through it. I'm going to pause the video, and I want you to like talk out loud. You can move seats, you can talk, and I want you guys to come up with the formula yourself, because here's another reason why. When you have a struggle with memorizing formulas, if you just know how to find height yourself and you don't even need to memorize a formula, that's when we're real power. You're like, I can problem solve for anything because I don't need the formula. I like knew how to derive it. Okay? So I'm gonna pause for a second, and I'm gonna stress also for you guys to put the effort into. Okay, so as you guys were developing your formula, I love that we all got almost to the same place. Okay? So you don't know the height, so we were going to write down what we know, and we're now here at the green part. And a lot of you did it. You're like, what I do know is law of sines or SOHCAHTOA, because this is a right triangle. Those of you who use law of sines, you're correct too. Those of you who did SOHCAHTOA said sine of 35 is h over 6. And by the way, it's okay that you wrote down and knew that that was 55, but it doesn't do us any good. We're just trying to come up with the formula ourselves. So then we realize, and so in case some of you guys didn't notice, I wasn't really caring about your answer, was I? Or was I caring about the connection? How it connects to the formula. So now I was able to find height. I could rewrite this and realize, oh, so this is also 1/2 my base. And then in this case, I had put a 6. Sorry, let me hurry and just kind of fix that. Let's fill in our base for the blue, okay? The blue is 10. And then we figured out our height using this. But once I figure out my height, I don't use it anymore. Because I think some people were trying to find the area of this. I still want the area of my blue. I'm not dividing this into 2 triangles. I just was showing you that when you guys want to find a measure, you can pull apart parts of something and calculate that measure based on that being a right triangle. But it's still the height of my blue. Does that make sense to everybody? So we just kind of pulled that little triangle out, calculated something, but I still use it here. So those of you who found it to be, what was it, 2 point something, 3 point something? Okay, so you guys found this to be, and again, I didn't really care much about it, and I love that you took it and plugged it in. You guys plugged in 3.4. I cared less about the 3.4 and more about you realizing that that was a 6 and that was a sine of 35. So now let's kind of develop the formula together. Instead of 1/2 base times height, and I can use trig, what do you guys notice? It was 1/2 my base times by the other leg, don't call the hypotenuse when it's here. Let's do this. Let's erase that now because we don't need it. I'm going to leave it actually for my notes. But the other leg, and then sine of the included angle. So do you guys notice that this leg and this leg was able to form this right triangle, and I was able to come up with the height. So therefore it works out that 1/2 my base times my other leg times by my sine of 35 is also a formula for a triangle. And you guys, if you ever forget it, could sit there and be like, well, I know how to calculate height. I'm just going to calculate height myself. So you don't even really need to memorize the formula, okay? So 1/2, let's call this one leg that makes up this angle. And then let's call this the other leg that makes up that angle, and then sine of that angle. Okay, these 2 legs come together there. Now this one got a little confusing because my height was outside. But I can still calculate my height because this is a right triangle. I do know that this is 9, but I don't know that angle. But I do know what about straight lines and linear pairs. What do I know about linear pairs?
Is it the same on one side than the other?
No, there's
No, they add up to 180.
they do have to 180, yeah,
180.
straight line,
Okay.
yeah. So it's called supplementary. So if right here is 100, but I'm trying to find the height like right here because it'll give me the height of this blue triangle. If this is 100, what is this?
80.
It's 80, right? So I can actually, using 80, because this is 80, calculate my height. Again, I'm not going to use the formula quite yet because we're going to get that on the next page, but we'd be able to say area equals 1/2, the base is 8, times by my height. Well, let's calculate height. What is the height on this one? Sine of 80 is equal to h over 9, right? And then if I solve for h, I would say 9 times sine of 80. So 9 times sine of 80. Now, this gets a little confusing. By the way, will somebody put this into their calculator really fast and tell me what you got? What'd you say?
35.4.
Okay, 35.4, but this doesn't help me. I thought my angle right there, by the way, these are units squared. So if these were in like centimeters, you'd say centimeters squared, right, you guys? I don't have it in centimeters or anything, but units squared. Hold on for a second though. I thought I was supposed to use a 100. Well, let's just try this. Will somebody else type in 1/2 the 2 included legs, which is 8 and 9, and why can't I just type in the 100? Why did I have to type in 80? I typed in 80 because that's how it worked, but I'm curious, what answer do you guys get when you do it with a 100 instead now? Oh, weird. Why is it that I can type in sine of 80 or sine of 100 into that formula and I got the exact same measure? My hint to you is how the unit circle worked. I can find sine of an angle, and remember how it was all students? Sine was positive in both quadrants, right? Where does 80 degrees fall? Quadrant what? 1. 80 degrees fell here, and I have a reference angle of 80. Where did 100 degrees fall?
2.
And what was its reference angle? It was also 80. So did it matter the fact that I was doing sine of 80 or sine of 100? Did it matter? No, it's because they are supplementary, and that's how they work when we're using the unit circle. Okay? Now, you guys just technically derived our formula. I feel like it's going to stick in your head a little bit more now that you derived it. Do you guys kind of agree? Okay, this only works when I am given a side, angle, and a side. So this is the included angle that's between 2 sides. Otherwise, you guys would have to kind of calculate stuff a little bit differently, okay? And what if I'm not given side, angle, side? You would need to what?
Find it.
Find it. You would have to find it using law of sines, law of cosines, or whatever is given, okay? So it only works for this. So this isn't 3 separate formulas. It's all dependent on what's given. For instance, if C and B are given and then angle A are given, I'm able to do it 1/2 B times C times sine of A. Notice how they're all different variables, okay? It's the 2 sides that are not opposite that make up an angle, right? And so those ones, or if I had sine of B, I could say A times C times sine of B. Or I could say B times A times sine of C. It works no matter what, whatever 2 sides make up an angle, you guys. That's the formula for using trig. So I'm going to give you 2 examples before we move on to the next thing. I am going to give you one where we gave you all the measures. So yes, you guys can sit there and just jump right into the formula or derive the height yourself or whatever you want to do. But I have a tricky question. It's number 6. What do you notice number 6 is asking? It gave us what?
X, Y, Z.
It gave us side, side, side. So I don't have enough information to possibly do the area. So we have to find it. Okay, we'll get to that in a second. So let's hurry and set this one up. Because I was given enough information, we could sit there and calculate height. We could sit there and realize that it's 1/2 base times my height, which is sine of whatever that reference angle is, 76 over 8. You know, we can do it. See, Marie? So you guys can calculate height yourself, or how many of you kind of have the formula memorized now that you now know why the formula works? Do you feel like you have it? Okay, so it would be 1/2 what?
1/2
9 times by, we would have done h, but we can calculate h as the sine of this reference angle 76 is equal to 8, or sorry, it's h over 8. This is our h, right? H over 8, and you guys would have calculated it as h sine of 76. So I don't even expect you to derive it yourself now. We hopefully just know the formula is the 2 legs and sine of the interior angle. Now, I didn't need to use 76. I could have used 104 because they are supplementary angles. They have the exact same reference angle. So I could have used what was given. Does anybody have the answer to this one, just so we have it in our notes? Everybody take the time to find it. And again, we could have used 70. Did I say 76? Is it 76 or 74? 76, okay. I wrote it down wrong here. But what do you guys get for this one's area? It's in centimeters, so let's write the units as well.
34.9.
You should have got 34.9 centimeters squared. Okay? Now, let's look at this one for a second. This one's number 6, so you guys might as well write it down in your assignment. I'm going to put my longest leg as 10. I'm going to make my next one that looks a little bit long, 9 and 4. I didn't really do a good job writing this to scale, but drawing this to scale. But this is my capital Y. What goes across from my 9? Is capital Z? and a capital X goes across from my 4. Okay, so at first glance, I try to make 10 my base. I try to make it like it's sitting on the ground, so forgive me for not looking awesome, but let's try this. I'm asking you guys to find the area of it. I cannot do 1/2 base times height because I don't have the height, so I need to be able to calculate the height. But what's tricky about this and everybody's deception is they think they can do Pythagorean theorem when they drop that height down because they have so many legs. But are we allowed to still? No, because I don't know height and I don't know that. You can't claim it's cut in half. I have too many kids who think I can just make it a 5. It's not cut in half. I didn't tell you it's a 5, right? So we can't use Pythagorean theorem. So we are technically forced to find an angle. Now, I made a mistake last time, and when you guys are given a side, first off, check that it's possible. Is it possible? Mm-hmm. Are my 2 small slides bigger? Yes. I also forgot something. Me and Cora were going over a problem, and it wasn't matching my key, and I completely spaced something that I need to emphasize. So number 11, you guys could have gotten 2 different shaped triangles, and here's why. Whenever you guys go to do the law of cosines and it gives you an angle, and then if you guys go to find another angle using law of sines, do any of you guys remember what angles or what we're restricted to when we use sine inverse? Are you ever going to get an obtuse angle out of a sine inverse? You're never. Your sine could run from negative 90 degrees to 90. So there's a problem here. If your angle could be obtuse, you shouldn't be using law of sines. You should be using cosines both times. Or, if you guys use cosines and find your biggest angle, then you guys would be able to just do cosines and sines. Does that make sense? Because once you guys find an obtuse angle, will your other ones be obtuse? No, they'll all be acute. So you guys can only use law of sines if you think your angle is acute. Do not use law of sines if you're doing it on your biggest angle of a side. Okay? And that is something I regrettably forgot to include in my video. So now since we're not solving this whole triangle, law of cosines works on anything. So that's what's nice about it, is it works on your obtuse angles, it works on your acute angles. Law of cosines always works. So do you guys want to find y, like the biggest angle, just because it's obtuse? Do you guys want to find x? Like which one do you guys want to find? And then we'll go from there.
Obtuse, revolutes.
You want to do that one? So you guys want to find y? Okay. If we are choosing to find y using the law of cosines, what has to be alone on the left side of this?
10.
10 does. 10 what? Okay, good. Fill in the rest. Fill in the rest here. So I have 4 squared plus 9 squared minus what?
2.
2 times 4 times 9? Okay, let's clean it up. I should have 100. And I should have 16 and 81. And then what does negative 2, 4, and 9 multiply to? Did we get 72? Okay, good. My 16 and 81 gets to minus over. What do they add to? 16 plus 81. Is it 97? Let's minus that 97 over. So that's a 3. And then what can I do with the 72? Let's go ahead and divide it. Okay? I'm out of space, it looks like, darn it. I didn't leave myself a lot of space. Divide by negative 72. And then what's my last step to get my big Y completely by itself?
Opposite of cosine.
Cosine inverse. Yep, always using inverses. Negative 3 over 72. Cosine inverse. So you're doing the cosine inverse of negative 3 over 72. What did you guys get? 92.3. It is obtuse. So you would have wanted to be careful. Am I going to do whole numbers or decimals on this one? I'm allowing you. Oh, I chose to find angle. You might be off of me because I chose to find a different angle. But that's okay. So 92 point what?
4.
4. 92.4. So knowing that we found 92.4, you could reorient this so your base is like your angle is different, or we could just realize that we know how to find area. We know that area now is 1/2 the 2 legs, right? So it's hard to know which one is your base because it's not oriented properly because we chose a weird angle. If we had found X, this would make more sense, but 4 times 9 times sine of 92.4. But if I had chosen x, I would have used those two. Or if I would have chosen to find z, I would have used those two. Does that make sense how the formula works depending on which one's the included angle? So I used 4 and 9 because I found 92. But if I would use 4 and 10 if I would have found z, or I would have used 9 and 10 if I would have found x. Okay? What do you guys get for the area? And let's call it good. And you're going to be off of me slightly if we use decimals differently. Or what'd you get?
18.
About 18. So about 18. 18 is our units on this one? No? So
No.
about 18 units squared. So if you don't have enough information to find area, are you guys okay to use what you do know to find parts so you can? Okay? All right. Now this is something we kind of brushed over and we saved it for a separate day. I gave you guys those spaghetti noodles last time to happen upon the side-side angle ambiguous case, but I didn't really go into depth, okay? Now, I want you guys capable of being able to find when it's 0, 1, or 2 triangles. However, in your homework, we actually just gave it to you. We actually gave you the 2 different triangles, but I kind of want you guys to kind of like write down the rule just so you know why. Why do we have this drawn as one triangle, okay? So bear with me on this part, even though we technically give it to you guys. Everybody okay with this? We kind of already talked about this. If I am given a side, and let's just call that side A, because it's the one that's opposite this angle I'm going to call A, okay? So side, let's just call this B because it's easy, and then angle. Okay, so side, angle is given. This is called the ambiguous case because sometimes you can have 0 triangles possible, 1 triangle possible, or 2. And I want to go through the different scenarios how you do this, okay? So I'm going to pick up these legs and I'm going to I'm choosing to put this angle A. Oops, I didn't want to do that. Let me make it a little bit longer actually. But I want to pick it up and like move it. There we are. Okay. I'm forming the, it's not letting me. This might not be perfect. It's kind of being like jumpy. It jumps like a big space. Okay. Okay. So let's take side A and let's talk about the comparison. And we got to compare it to height, okay? So I'm going to pick up this and just move it. It was letting me do it earlier. Yay, it's letting me do it. So remember, the shortest distance is height, right? So we're going to call this straight down distance your h. So in comparison to height, if A, let's do our 0 triangle scenario. No triangle was possible if what?
If H is...
If A was what? Let me make it look like it now. I'm going to make this too what? Too short. So if your A happens to be less than your H, it's impossible for a triangle to form. And then how about the 2? What did we learn last time? That we were able to get 2 triangles out of the exact same measures. It has to be longer than what? H. Longer than H. This is A.
And longer than B?
Not longer than B. I have to be able to go this direction, but I could have also put that same exact size that direction. So it has to be shorter than B.
Oh, okay.
That's this triangle. It's either that way or that way, right? So A, the opposite leg from the angle given, is now longer than H. It's longer than H, but it does have to be less than B. Because if it was longer than B, that would be a 1 triangle scenario. So like the 1 triangle scenario is if A is the H, but also if your guys' A is bigger than B, it's also for sure bigger than the H. Let's go through that, okay? So let's take A again and let's put it where the height is, okay? We're going to make it well bigger than the height, but we're also going to make it way bigger than B. And look, I can't touch in 2 places. I can only touch in this 1 spot. Does that make sense to everybody? So that's the only 1 triangle is if it's bigger than A. So this is the 2 triangle scenario, okay? How you guys do this is you technically can find out if there's 0, 1, or 2 triangles by comparing it to the height, okay? So like if I wanted to be like, hey, is this a 0, 2, or 1 triangle? I would go like this. I would say, all right, I'm going to call this 30. I'm going to call the side opposite it 9, and I don't know for sure if it can touch the other side yet. And then I'm going to call this B. Well, 9 is less than B, So I for sure have to calculate it and compare it to what? Height. So you take a moment and you find out what height is. And we're so used to finding height, this is not a big deal, right? We know how to do this. This is a special. Can anybody do this in their head without a calculator? Just for the heck of it. Let's apply to what we've just learned. What's sine of 30? 1 over what? Do you guys remember what sine 30 is? 1 over 2. Sine of 30 was 1 over 2. So this is 9. If my height is if my height is 9, then what is this? Is this a 0, 1, or a 2?
Isn't it a 1?
It's a 1. Your A is the height. Yeah, this is a 1 triangle scenario. Now, we're not making you do this. This is what this is what honors kids would be doing, okay? In advanced college classes. So, to save you guys time, let me give you a hint on what we gave to you. We're going to do 13 through 15, and then there's another one after that on numbers 16 through 18 that's just reoriented like differently, okay? Okay, here we are. Okay, step back and look at it. And what this is what if it's this way? So there's this triangle.
ABC.
And it's still 10, 20, and 25, right? Let's just call this ABC. But what if that had swung that way? And supposedly if we took the time to find what height is, it's possible, right? So we're telling you it's possible because we already drew these triangles for you. But what if I chose to swing that 10 leg this way? It's a completely different looking triangle, but look, I still have the exact same measures. And this is A, this is B, and this is now D, okay? So on your homework, on number 15, 16, and 7, or 13, oh shoot. 13, 14, 15. 13 we asked for angle ACB. The next one we asked for ADB. And then we asked for DC, okay? Now this is where it gets a little bit tricky to wrap your head around, okay? I'm going to go ahead and solve for this ACB, so it's this one. We're just going to call it C for the sake. Go ahead.
Are there still like equilateral triangles?
Hey, I'm getting to that. But yes, let's do it. Let's actually do it because he brought it up.
10 to 10, actually.
Because when these are in one together, what are we technically forming? Yeah, you said it though.
Hey, wait, is it
I saw
now
some.
45 now?
This is an isosceles triangle, not
That's
equilateral, but I
45,
like that you were on the right track.
45.
What do we know about, not 45, but what do we know about isosceles?
The two bottom angles are the same.
Two bottom angles have to be the same. So once we know C, we should also know this one.
LD.
And that actually helps us with this question in a second.
I'm just looking back.
So I'm really glad that you noticed it because it actually helps us here. Okay? And when I ask you to do this, you're going to be able to do law of sines because once I know these two angles, I also know the third. And so for you guys to answer number 15, you guys are going to already know. You guys will know B because you're going to know the bottom ones. So that's for 15. Okay? All right, let's finish for 13 and 14 really fast. This is where it gets a little confusing, and this is why we expect the older, the more advanced classes to have to come up with it because it's so hard to wrap your head around. But look, let's set this up. How can I find C, you guys? We know law of what? We know law of sines. So let's set it up. I want to find C, so I can do sine of C over what?
20.
20 should be proportional to what?
Sine of 25.
Sine of 25 over
10.
Okay. But here's the tricky part. Isn't it the same setup for D? And how is that even possible? Isn't sine of D over 20 also going to be proportional to sine of 25 over 10? And this is where it gets confusing. Will sine ever push out an obtuse angle? No. So you had to recognize when they're put together that this is an isosceles triangle, and so we'll get to that. Let's hurry and solve for C, and let's solve for D, but we got to extend on that one. Someone hurry and help me solve for C.
It's just gonna be 20.
Sine of C is 20. Sine of 25 over 10. And then what do I do to put in my calculator now? C will be sine inverse of all of that. Do you guys agree? In order to finish my sine here, I have to take sine inverse, right? Sine inverse. Everybody good? Okay, what did you guys get when you put that into your calculator? You do the work. What's that?
57.7.
50, is that what most of us got? 57.7. It's 57.7 degrees. Great. And I'm gonna, let's see, did I make it 58? Let's, for easy numbers, call this 58. Now, here's the tricky part. I want you to do ADB too. ADB. And watch what happens. I'm gonna still times by 20. We're gonna do the exact same work. Sine of D is gonna be the exact same solving and the exact same thing we put into our calculator. So we're gonna be like, what the heck? This is, how am I supposed to have them both be the exact same measure? Because this one is clearly obtuse. It's clearly obtuse.
But because of the circle thing, you can't get it because it sign can never be that.
Hold on. Let's do it based on the visual that Anthony kind of realized.
So you just minus
So-
20.
Yes, who just said that? You do. AD, what's this one asking for on this homework? ADB. Angle ADB is not this obtuse angle, okay? Is not this acute angle. Technically, because these are isosceles triangles, this is what's 58, not ADB. And Eric just realized they are a linear pair. So since they're right next to each other, and kind of what you were saying, they would give us the exact same reference angles when we were doing sine of it. So you would do 180 minus 58 to give us the obtuse angle because that one's obtuse. So you would have to, this is where it gets tricky, is you have to recognize it. You're like, oh, I just recognize it's the obtuse, okay? So it's 180 minus 58. What did you guys get?
122.
122. Very, very good. So you guys would have gotten this to be about 122. And now, do you guys have enough information to know this so you guys can do number 15 and set up the law of sines? Do you guys know what angle B is? I'm going to make you guys do the work. You guys know this because those two are 58. It should be 58 plus 58 and then minus that from 180, right?
Oh, for 68.
Yeah. So now you guys can do it. And you guys can finish 15. So this is what it looks like to have the ambiguous case. And for you guys to realize you have two different triangles. You have this one that's 25, 122, and whatever that angle is. And then you guys have this one, well, sorry, down here, that this one would have been, oh, I apologize. Yeah, 25, 122, and then you can get that one. Or you guys have this bigger one that was 25, 58, and then we can calculate that one up there. So that's what's kind of cool with the ambiguous case is you have two separate looking triangles, okay? And that's my hint to you on your homework. The last thing I wanted to go through was let's do number 12 together, and this is where you have to decide, do I use law of sines or do I use law of cosines, okay? You have to kind of pick and choose. So let's do number 12 to feel like you get a head start on your homework. I already gave you a head start on 13 and 14, but I feel like this is worth doing. Before I even draw a picture, which one would you guys, oh wait, which one are they asking for? What's 12 asking for? Anything? Or just solve the whole triangle? Oh, I didn't say it there, I guess. That's my bad. Oh no, did it freeze on me? Please don't tell me it froze. Am I okay? So it looks like I forgot to write solve for B. Now there's a reason I chose, sorry, I thought that was a C, so just kidding. I thought I meant to choose this one for a reason, but that's okay. All right, you guys, which one would we use? Would we pick law of sines or would we pick law of cosines? We would pick law of sines. Why did you pick it, Eric?
Because it gives you like no sides for it.
It gives me an angle on its opposite side. So we can draw a picture. You guys are more than welcome to draw a picture. And if you're off, who cares? I don't care if you guys are to scale. You are more than welcome to draw a picture. But I'm going to do this based off of me not really looking at my picture. Is that okay? I'm going to do it based off of this. What am I forced to find? I do know sine of 20 over 6 is proportional to what? What am I forced to find because of what's given? Look here. What am I forced to find?
Angle B.
I am forced to find angle B. Does that make sense? Now, what if I had asked you to find C, actually? Am I still forced to find angle B first? Yes, there's nothing else you can solve for. I am only able to solve for B. So what if I had said find sine of solve for C? You have to do all that roundabout steps. So when you guys are missing a piece, you sometimes have to solve two different things before you can get to your answer. All right, and then we're done. So you guys would have got sine of B is equal to, looks like we're going to times this 10 out of here. Times this 10 out of here. So 10 sine of 20 over 6. Then what? What do I do to find B? What goes into my calculator here? Sine inverse, I heard. Good. You guys are awesome. Sine inverse. And you guys have it. Does anybody have the answer to this when they get done putting that into their calculator?
34.75.
I heard it kind of quietly. Say that one more time.
34.8 to 10.
34.8. Now, here is, we found a degree. Here is the tricky part. This is why I kind of don't like log signs sometimes, but could angle B potentially be obtuse because it's across from maybe possibly my longest leg? It could be. So based on the way I drew it, it could be obtuse, right? So what's tricky is we are forced to solve for this, but it is across from the biggest leg. So you got to be kind of careful. If we did this a different way, when we were looking in here and we were looking, when I'm given a side-side angle, so this is a side-side angle scenario, and so since this is a side-side angle scenario, we have to be careful because, oh, okay, this could be the situation where I actually have two. And so right here, if we want to calculate the height, we probably need to realize that if a triangle is even possible, what if the 6 needed to go that way? So our other angle could be, angle B could be this 180 minus what?
That number.
Let's call this 35. So what could this be? 180 minus 35. So it could also be 145. So you got to be really careful because how do you know it was an acute angle? Sine will never ever push out an obtuse angle. So you've got to be really careful on side-side angle and the chance of it being two triangles. And that's why I chose to do this one. This one was a two triangle scenario. We gave them to you on most of them, but try to be aware of it if you guys see that, okay? All right, I am done. I'm going to let you guys be. I feel like we talked a long time because there was so much discovery today.